Hello there, may I introduce you to my friends? Hey, at the end of this video you can watch them a little longer having quite some fun and obviously also quite some stress with each other. Hey Bruce, say hello. But first to the filters. ND filters are so nice for allowing you to keep your lens wider open in bright sunlight, to have this nice bokeh, and also to use slower shutter speeds for nice smooth waterfalls and so on. But today, something completely different. Variable ND or neutral density filters actually are two polarizing filters that can rotate. So here we take advantage of just this construction principle. Sure, this could also simply be a video about polarizing filters. However, most of us who shoot video already have a variable ND filter. Plus, often in situations when it makes sense to use a polarizing filter, you might also want to have an LD filter on. Now, just a little bit of physics here. The usual idea of light as a wave is not so bad, only it is a bit more complicated. Apart from the fact that light is electromagnetic radiation, so it always has two components, an electric field component and a right-angled magnetic field one, that we simply ignore here and only focus on one component. So apart from that, light can oscillate in different directions. If you look into a normal light beam, we have waves oscillating in all possible directions. Light that only oscillates in one direction or changes with a constant rotating pattern is called polarized light. Natural light that is coming from our sun or most other light sources usually is not polarized. But it can be polarized, usually by simply taking away those parts of the light that do not oscillate in a given direction. Or bit more precisely, as every orientation of an oscillation can be seen as a superposition of two right-angled directions, a polarization filter allows to pass through all those components of every wave that oscillate in a given direction. Roughly speaking, a small band polarization filter filters out around 50% of the light, while most actual filters filter out less. And the light that comes through is usually not perfectly, but pretty polarized. And if you put a second polarization filter behind it, you can take away even more light if you rotate the second against the first one. That is what a variable ND filter does. But there are also natural processes that can polarize light or filter out certain components. For example, a water surface like in a pond or a swimming pool. Here, some light oscillating in a certain direction will more likely be reflected, while the rest can go through into the water. Now, if you want to take a picture or video of something inside the water, a fish or a hard bikini or whatever, you definitely don't want to catch the light that has been reflected at the surface. On your sensor, you want the light that went into the water and was reflected by that fish, so you can get a nice video of his bikini or whatever. This is where the polarizing filter in front of your lens enters the game. If it is correctly orientated, you might want to turn it a little bit. It just gets rid of the reflections from the surface and allows the interesting light to go through your optics. Physics lecture finished, and yeah, I have studied physics. Bottom line, polarizing filters make it easy to look into the water. As a variable ND filter is a combination of two polarizing filters, they can often be used as well. Not only are they sunglasses for your optics, they are also magic look-through glasses. The footage I took last fall, when it was really sunny, took advantage of both of these filters' abilities. The footage of the hot, funky frogs was taken on a very cloudy spring day, so only the polarizing filter ability was actually used. So, this is it. Another reason to own and use variable ND filters. And now, as promised, a longer sequence of some frog adult footage. Thanks for watching.